In this video, we're going to learn how to apply E in some real-life situations. To begin with, we're going to use the natural base to help us do some more investment problems. In section 8.1, we use the investment formula A equals P times 1 plus R over N to the RT power, or excuse me, to the NT power, where we had A be our final amount. Oops. This is our final amount. R is our percent rate that we're given for our investment. N is the number of times we compound, so number of times we compound per year. Number of times we compound per year. P is our principal, our starting amount, right? And T is our time in years. Now, one thing that happens that's kind of interesting is you can compound more and more and more per year, and you can actually compound continuously or just infinitely many times. So if n goes to infinity, right, if we compound infinitely many times per year, this expression 1 plus 1 over n to the n power, which is essentially our base, right, of this exponent, this goes to e. So if we compound continuously, or we say continuously compound, we use a different formula altogether. We use A equals P times E to the RT. This is a lot easier to use. You can see you don't have to worry about N anymore, and that whole fraction as the base. It's a lot easier. Let me show you a couple of examples. In example 5, it says, let's deposit $1,500 in an account that pays an unbelievable interest rate, 7.5%, that's compounded continuously. Guys, as soon as you read compounded continuously, you should write PE to the RT. That's going to be your formula. Well, we know the P value for this is going to be 1,500. We know the interest rate as a decimal is 0.075, and we're doing this for, I think, 1 year for part A, so T equals 1. So our amount A is going to be just 1,500 for P times the natural base E raised to the 0.075 times 1. So in my calculator, I'm going to literally type in 1,500 e to the 0.075, since 0.075 times 1 is just 0.075. So if we bring up our calculator, oops, I'm going to type in 1,500, oops, let's try that again, 1,500, and then second ln to get e to the power, and I'm just going to do 0.075, and we'd have $1,616.83. So let's write that down. That would be our solution for this particular problem. We're going to have, after 1 year, an amount of $1,616.83 if we just round to the nearest penny. If we did this for 10 years, everything's going to stay exactly the same as far as our amount for P. Our principal is still 1,500, and our interest rate is still 0.075. Here, the time value, though, is changing to 10 years. So in the calculator, it's going to go 1,500 e to the 0.075 times 10. Now I know if I multiply 0.075 times 10, I'm just going to move the decimal place over once. So I'll save myself a little work and just put in 1,500 e to the 0.75 power. And let's see what happens. 1,500 e to the 0.75 power, and I get $3,175.50. So for this problem, our final answer would be an amount of $3,175.50. Let's do our last problem here that I'm going to show you in the video. What if we did this for 50 years? Well, actually, I think this would be a good one for you guys to try. I would like you to calculate how much you'd have after 50 years. Maybe this will be one of the ones we'll have to check in class. The last example